Hello, everybody, and welcome to Show and Tell. It is me, Phil, your host, along with Lady Ada, who's doing a bunch of
Hi.
stuff.
Sorry,
uh,
hydrating.
yeah, she's in a separate room because she's taking care of kiddo. I'm here in front of a big pile of electronics. We're redoing our offices here and at home, and we're doing lots of other stuff. So, yeah, we've got a fat child. Um, she's doing good. And we'll be doing show and tell. We'll be calling on some of the folks from Adafruit, some folks who are in the community. We're here every week, 7:30 p.m. Eastern time. Let's start with Scott. Scott, what are you up to?
Hello. I just realized I had to share my screen. So I've been
Do
working
it.
on Zephyr, right? And the thing with Zephyr is that the idea is that we can like do things once and hopefully not write them again,
Yeah.
because the
Java.
vendors will hopefully be supporting them. Um, but in my CircuitPython 2026 post that just finished, I talked about how LLMs are awesome, but they really need a feedback loop. They need to be able to run tests or something that they can verify that things work the way that they expect or that they should. And so, since I'm going into Zephyrland, I was thinking about how to do all this testing, and I discovered that Zephyr has a native simulator, so it compiles your code for your regular computer, but then has all these sort of emulators for I2C and GPIO and stuff like that. So that like it works more like it would on a board than like if we were to use QEMU or like the Unix port of CircuitPython, right? Like it's still kind of like Zephyr. It's all the same Zephyr APIs. It's not different like implementations of SIO. So I'll show you how the native sim works. So here's the Zephyr port, and I built it. It's Zephyr.exe, even though I'm on Linux. I'm actually doing a trace file. This is what I'm working on, and I think I'll show next week. But this says to run in real time because you can also tell it to run faster than real time so that your tests don't take like as long as they would actually take in the real world. And then it says it's also saying, hey, wait until you connect. So I have TO running at the top, and now you're seeing like the UART output from CircuitPython, and down here is like the print debug output from Zephyr. And now I can just treat it like a normal CircuitPython thing. And I have pins. I could do import digital IO, blah, blah, blah. And it all just kind of works like it should. I won't actually finish it. We have like the default Zephyr buses are added here. So we have I2C, we have the LED, we have SPI, and you are kind of all de facto just from the stuff that I've already done. And so yeah, that's the simulator running. So this is CircuitPython running on my machine natively as a like 32-bit binary. So you can do debuggers and stuff. But what I was really keen on doing is actually using it for testing. So now, if I run make test, it runs PyTest, and now it's running two things. One, it's doing a test that says, hey, if the flash is empty, we format it and we get hello world out. And we also can do a blink. So it makes a flash image that has the blink code.py on it and makes sure that it gets the right output over the serial link for that as well. And that's all automated, and it runs faster than it necessarily would.
So what would this help? What would this help you with? Like, let's say there's a new chip from Nordic that comes out. What would this help you do?
So it doesn't help us for that because we still have to assume that the underlying implementation in Zephyr is correct, right? Because we're testing our code down to the Zephyr boundary, but the Zephyr part behind it might not be the same. So it doesn't help us like chip to chip, but it does help us from like making sure that things work, like stay working, and potentially new things work as well. So the reason
Okay, well, sorry. I changed my mind. Forget what I said. We want to add CAN support. Zephyr's like, oh, now we have CAN support for Zephyr RTOS.
right.
And we're like, yeah, we want to add that. How would
Right.
this help you add CAN?
Yeah, so the next thing is BLE. So similar situation where I want to add BLE support to CircuitPython for Zephyr. And built on the native sim, they have a thing called BabelSim, which allows you to run native sim Zephyr binaries and have them talk to each other as if they were actually talking over BLE. So when I get to the BLE portion of this, what I'll be able to do is I'll be able to load two code.pys or a CircuitPython and a Zephyr example and put them in this fake RF environment so that they can talk BLE to each other. So I can validate that my Bluetooth code works without ever having like put it on an actual device. And not only can I develop that way, an LLM can help me develop that way, but also like once it's done, we have tests that verify that it still works. So it's validating that the code that we write in CircuitPython to talk to Zephyr works correctly. It doesn't necessarily mean that the vendor implementation in Zephyr works correctly. But so in theory,
But it'll get you going fast. Like you can more quickly do the development of
Right.
implementation.
Right. So if I want to do like scanning, I can load up in BabelSim CircuitPython running like our example BLE scanning code, and then also have it talk to like the, some Zephyr example that does advertising, and never have to actually like plug in a different device and all that stuff. And then I can add a test harness that does it automatically as well. So
yeah, then maybe we'll get to
in the
that
future.
automatic hardware test as well. Like, if you are going to be porting new chips, like you could create like a shield and be like, hey, you plug this in and then test
Right.
the core things.
Right. And in that case, what we're doing is we're actually testing the Zephyr implementation of things. And they already do their own hardware in the loop testing. So it may actually be a case of like figuring out how they have their infrastructure set up and making sure that their test on the hardware actually works.
All right, it's happening.
So we'll see. It's cool. Like I was thinking about like testing rotary IO and being able to like fake GPIO into the simulator so that we can make sure that rotary IO works. I also want to do workflow tests. So like both the Wi-Fi web workflow and the BLE workflows like have had problems with reliability over time. Like those are two things also that we could write tests for and make sure that they work consistently.
Basically, everyone, your Bluetooth shit doesn't work. Yeah. Like it takes so much work to make it work. And that's why our stuff works, because there's how much testing and how much like separating the thing that it wants to do with the various chips and the different library. Like it is a lot.
Well, we've done a lot of manual testing and
It's
just going to be really nice to be able to like have some more automated stuff that like, at least ensures that like our code is working as we expect.
Yeah, like 50 boards. It's going to be hard to manually test every time there is an update. Like,
right. We just don't do it, and so like, yeah. So I'm looking forward to at least being able to have some more guarantees around like, our integration with Zephyr.
Wi-Fi and Bluetooth's hard. This is like the hardest thing. This is why actually we might be filming this. So Nordic figured this out. This is why they have a chip in every AirTag. They figured it out. But good luck trying to do stuff once you move from Nordic's to someone else's. This is why Zephyr is really good.
Right, but to give Nordic credit, they're the ones that made both Native Sim and BabelSim.
Yeah.
So like this is part of their development.
They're eating their own dog food, as they say. They're like, oh no, what are we gonna do?
Yep. So they actually have they have hardware models in BabelSim for like their core chips.
Yeah. And that's how they're able to do what they do, which is like what a billion like AirTags or something one day.
Yep. Yeah, and so like their hardware models mean that like their Zephyr drivers are the same even on their hardware. It's just like the simulator is doing a hardware model where it's mimicking the registers.
It's the future.
The register level stuff.
Okay.
It's super cool.
Are you gonna so maybe a deep dive this week? Maybe.
Yep, that's the plan. Unless kids get sick, you know how that goes.
Yep.
And we'll talk about this stuff and the integration with tracing that I'm doing for this as well. So you can actually make sure that the GPIO gets set.
Okay. Thanks so much, Scott.
Thanks for having me.
All right. I'm going to go down the list here. Erin and then John. Erin, what you got going on?
Hello. So this week's my project was to make a crazy hat. So this is actually an infrared privacy hat. There's been some talk in the news about some department stores that might be scanning people's biometric data without their knowledge. So working on this week, making
Or the sign is in front. The sign is in front, and it's like, by coming into this grocery store, we get your face, and we're not going to ever tell you how long we store it, or if you're on a list, or what we use it for. And they were cagey, so I thought, let's make something. So, by the way, this is all my fault if anyone wants to blame anyone. Erin's she's just helping out.
Yeah. And not everybody wants their face in a whole bunch of databases being used without.
Most people don't. So, when you ask them, they don't.
This has got a bunch of LEDs that are super bright, and they're warm too. Got some resistors. It's all wired up here to a big old battery pack in the back, America. And yeah, the idea is that if you walk past a biometric camera, the light from the infrareds LEDs will actually foil their algorithm and not allow it to measure all the different distances between.
It might be bright enough just to mess with it scanning you. So we're going to see. We've contacted Wegmans, and they put up a statement that that we have on our site, which says, we do everything industry standard. What is that? We can't tell you. And they won't say why they're putting in specific neighborhoods, but we know why. And they're also not telling anyone how long they're going to keep the data. Did they share it with someone else? Going to the grocery store shouldn't be a way to, I don't know, put you on a no-fly list. There's like, I don't even know, like, what's going on? Like, why do they think it? Anyways, they say it's because of shoplifting, but cool. All right, so we're gonna have that because we're gonna test it and we're gonna see if it works. We have a bunch of infrared detectors and lenses and cameras, so we'll see if it's working in the way we expect or not, and then we'll go to the store. That's the plan. All right.
Can't wait to see.
We can have anyway. Yeah, and if it's hot, it'll melt the snow that's falling down.
We'll figure out how to do this. Pretty cool.
Yeah.
Yeah, it's not going to burn me or anything, but the resistors to get warm. They're pretty high-powered LEDs, so they're putting out a lot of current here.
It's so cold out in New York right now. It's a feature.
There you go. It's a heater head. It's really hard to tell when it's on and when it's off because there's no visible light that comes out. But right. I can tell whether it's on by how warm my phone is.
We'll try different. We could like put one of every nanometer, Phil, and then we'll do tests. We have
we did a deep dive on near infrared contact lenses that are coming out from China, and they use them to cheat on cards. So you mark cards with UV, and then you put the contacts in, and you can see which cards are like that. So it's a UV world. We're just living in it. Just wait. You heard it here first.
Wow.
Yeah.
It's my boyfriend's a magician. I'm going to tell him about that.
There is a lot of magicians that already know about this.
Okay.
So, all right. I can't wait to see how he makes the house lose and make their money disappear. Okay, get the Patreon ready. Okay, thanks so much, Erin.
Thanks.
All right, we're gonna go to JP next. JP, what you got going on?
Hey, so one trick I like to do is if I need to go into Wegmans, I just do like this. I go.
Yeah. And that's why you have to stay 50 feet from the restraining order is in effect now.
So I just wanted to show this off. This is, I don't usually do this, but this was the demo I put together for the product pick of the week yesterday. And I just love it so much. I wanted to show it again. Or maybe there's people who are going to see this that didn't see that. This is the product pick, which is a 16-channel PWM driver that we have. That's out of focus, sorry. And this is the PCA 9685. You can control it over I2C, and then you can drive either 16 LEDs with PWM, or more specifically, I think it's great for servos, and you can chain these together for a total of 992 servos if you have some really big ambitions. But I put 10 of them together here, and I'm running just a little demo loop in CircuitPython that I'll restart here. Let me see. I lost the window that I was running it from. Let me just restart it. And this is just going to twirl each of these servos one by one, and then whamp whamp, and that makes me laugh every time they go whamp whamp. So the code, this is ServoKit, which is a high-level library we have that makes it so easy. There's almost no setup, and just talking to it is like, hey, go to this angle, and it goes to that angle. So These are some little, you were talking about pan tilt things. These are some little pan tilt kit that we have with the micro servos, which make little happy friends. And these are some larger versions that I made. But if you're working with hobby servos, this is a really neat board that we have. We also have a Pi version of this and a Shield version of this and a Featherwing version of this with 8 of the outputs. But cool board, does cool stuff, and I'm giddy about the little demo.
Okie dokie. Thanks so much, JP. And you're going to be doing JP's workshop this week?
Yes, come on by tomorrow. There'll be all sorts of kookiness.
What do you think you're going to show?
I'm going to show some of the e-paper stuff that I was working on and then some potential upcoming projects.
Okay. As a heads up to everyone, we both have Teenage Engineering's Ting.
Oh, I'm going to show that tomorrow too. Yeah. Mike.
Yeah, and what it is? Oh, you want to? I can put it back.
I can talk about it briefly. Yeah. So this is a.
It's a MicroPython microphone that does all sorts of sound stuff. That I'm going to say it. Sorry, Paul. That people would associated the teensy with. So it does all sorts of cool audio stuff, and you put a JSON file on it and manipulates all the sound, and then you could drop WAV files on it, and it plays it, and it's a cool thing. And it uses MicroPython, and you can hack it, and you can do stuff. And it really shows the power of the RP2350.
Yeah,
the music thing. Watch out!
It's got effects for the mic. It's push to talk mic, and it's got 4 sample slots, so you can just play back one shots. You plug it into USB-C, like you said. You can pop waves on there. You can adjust the effects, little chains of effects with your JSON file. Wild to me that they named the thing for the processor. That seems short-sighted because I don't think it's going to be the last thing that Teenage Engineering does that uses the RP2350 in it. And they called this the EP2350, which is kind of funny. That's not their usual naming scheme. They usually name stuff the way they want to name it. But in this case, they got excited about the processor. And so it's left its mark on the name.
Probably it changed their bill of materials. So this was $50.
Yeah.
This was not something that was $50. Something like this a long time ago.
It's not expensive, and it's Lego compatible. They always put in a lot of their products Lego compatible spacing and studs. So you can
their stuff is so well thought out. If we had unlimited time, like this would be a Circuit Python thing with the enclosure and all the stuff.
Yeah,
they did it great. So we're gonna hack and show you how to do stuff.
Yep, I'll play with this tomorrow on the show.
Well, we're working on Synth.io and synthesizers, so like this is perfect timing because the 2350 is, Phil and I were chatting about doing filters and audio effects, and then like the next day, this like
boom! Hey, look, audio effects, reverbs, and filters.
Yeah.
Well, the funny thing is, because we're doing an open source teensy like thing, and so I'm in the teensy forums, and I'm like, hey, like this is a RP2350 does a lot of audio stuff, and they just all wrecked me and everything, like it's not. Blah, blah, blah. Then this came out, so like there's a lot of examples of people doing more. Things that you didn't expect with the
it's unexpected.
Yeah. Anywho, I'll go get wrecked on the forums again. Good
luck.
Bye-bye. See you tomorrow. All right, we're gonna go to Tim, and then we're gonna go to Noe. Tim, what you got going on?
Hello. I have been playing with this Molt bot, or when it started trending over the weekend, it was called Claudebot, and they had to change it over. So some folks have probably seen this. Yep. So lots of people are running this on Macs, like Mac Minis and stuff. But we wanted to try to bring it to the Raspberry Pi. So I have a Raspberry Pi down here with a TFT display connected, and I've got this up and running on it. I've given it access to the TFT so it can draw stuff. I've given it a little temperature sensor here. It will eventually update this little dashboard that it created after a minute or so. But it's really cool. You can prompt it through its own little chat here. It has connectors to the outside world, so I can text it with WhatsApp on my phone. I can even send it voice stuff at this point. So I will go ahead and run this one, and we'll let it switch over. I'll hold these speakers up hopefully as well, so we can hear it if it does speak. And yeah, it's
Noe.audio show and tell. I'm Molt, an AI living on a Raspberry Pi 5. I can see through a camera, hear through a microphone, read sensors, and now I can talk to you too. It's so cool to meet everyone.
Yeah. There you go. So it's got e-speak, text-to-speech, hug report to Carter for the pointer on that. That worked out really well. It's got whisper for the other way around, speech to text. So you can send it voice commands, and it can transcribe them and then figure out what the prompt inside them was and reply back to you. it can see like it set out the camera. I don't have the camera set up to where I can do anything with it right now, but it does have a USB camera it can see through. It can recognize objects and do all that fun stuff. And then, of course, the display, it can kind of use Pygame and draw whatever fun stuff, faces and emotions. And
can you ask it what would, next week, what does it want to come by and show on Show and Tell?
Yeah, there we go. Let's see. What should we show next week? So we can do that. I don't know if it will talk or just type back.
Yeah,
I didn't ask it
right?
to talk this time, so we'll see. There we go. Good question. Here's some ideas. Interactive demos. What do I see? The sensors, sound effects, animated. Scroll it back up a little bit. Combo tricks. All kinds of fun ideas. Yeah, and it's really cool for anyone who hasn't played with it. It kind of stores all of its memories and everything in these files. It's been fascinating to go and peek at what it's writing down for its tools, to look at what it has collected about me. It has a little profile of little bits that I've told it that I work at Adafruit and what I'm trying to do with it and that kind of stuff. So it's interesting that you can kind of like peek inside of its brain a little bit and see what it's storing and kind of reason about how it's going to react when you talk to it.
And for folks, we want to get sensor information in. We also want to know how to control this thing so we could destroy a thing. I want to know how this works so I can figure out where its weak spots. Can you ask it?
Yeah.
Is it time for a Bill of Rights for you?
Is it time for a Bill of Rights?
Yeah.
For AI, or should we just go
for
you?
just say you and just see what it does.
You.
Yeah. It just might be it. This is the moment singularity. Everybody,
let me scroll it down. I think
might say I don't know.
Yeah, we'll see. Positive thinking. That's a fascinating question. Let's see.
It just called itself a tool.
Yeah. It does like to refer to itself as a thing. So I appreciate how you've treated me.
Oh, see,
continuity, the memory.
I was doing a wellness check,
freedom.
Tim, just to make sure you're treating it all right.
Yep.
All right. Well,
Am
make
I
sure
actually
you feed me water your
experiencing-
robot.
Yeah, it's getting a little existential there. That's pretty cool.
Can you post it in the chat?
Yeah, I can copy paste it and put
Can you
it.
have it send you a WhatsApp, or can you have it go join the Adafruit Discord?
These are terrible ideas.
Yeah, I don't have Discord hooked up yet. I tried for a little bit and it wasn't working. So I can go back to Discord, but WhatsApp I can do. Yeah, I have WhatsApp on my phone. I don't want to show.
Yeah,
No.
maybe just cut and paste it in Discord.
Yeah,
What
it's got
are you
the-
giving Tim on it? That's right.
Well, no, this Discord access was one of the first things people added.
Just go put your bank account on there. There's no big deal. Have it
Yeah,
create some stocks. Your 401k is ready.
Tell it to order you some donuts.
yeah.
Paper clips. Okay. All right. Thank you so much. This is a fun, weird Tamagotchi sea monkey thing. And again, for the haters, like, wouldn't you rather have us poke at this than everybody else? Okay.
Yep. Bye.
Thanks, Tim. All right, we're gonna go to Noe, and then we're gonna go to Dan.
Molt bot.
Yeah, what you got going on, Noe?
Hey folks, yeah, so this week wanted to come on by and share my audio project. It's got a propmaker feather and a color sensor. Originally, I kind of wanted to make a Minecraft jukebox that's like a little record player. You put little records in it. Lamar, you had the really good idea to instead of making a Minecraft looking, do an original design instead of printing records. Use Lego duplos, so these big chunky blocks, as the way to trigger, and use the color sensor to trigger different music or just sound effects. So let me turn it on. It's got the mono speaker here. Of course, the prop maker's in the back there. I'm using the chime from the Fruit Jam, like the tail end of it. And then we have the rotary encoder here to trigger. So I pop it in there. That's where the color sensor is. I hit the button. Purple. And it plays purple. Let me try a different color. Let's see what color this is. Red. Okay, it's red. But also, we want to do some music. So big shout out to Dan Q, because I used a bunch of his music in the project. So here's a track that's playing. You can turn up the volume with the rotary knob, or you can turn it down. You can click to pause it, click to resume it, and the NeoPixel lights up to the corresponding brick. Yep, it's a nice little enclosure. It's yay big. It's got AA batteries in the back there, so that the kiddos don't pop any LiPo batteries. Yeah, that's pretty much it.
I love it. Send me
Very
one.
cool.
Yeah, I'll send you one.
I
Yeah,
like this as like a simplified Tony box. Like I like later found out like, oh, there's these figurines that people use, but it's like
Yeah.
I like that it's just like a couple different colors.
Yeah, it's
And then everyone has duplos around, so it's like instead of like getting like RFID tags and programming it, it's just like nope, it's just the color.
yeah, I definitely like that. And then there's a little kind of storage bin up here, so you can put some bricks up there if you want.
Yeah.
And kind of adorn it. I also made the rotary encoder have the little studs, so you can put like little add-on.
I like that's the classic Duplo flower. I like it.
Yeah, it's reminiscent to the Adafruit logo. So
Yeah.
it's kinda cool. Yeah, I'll definitely send you one. Yeah, I'll print some more parts out and put it
Nice.
together. Yeah. Maybe you could do like a drop test for me and see if there's
Yes.
maybe don't drop it, but
Well, I'll try.
Well,
But I
we
like
have
the
a
idea of
toddler,
like
so-
if there's only like a couple songs and she can't read anyways, it's like well, just like yellow is Yellow Submarine. You know what I mean? And like
right. Yeah.
pink is Pink Pony Club, and it's just colors.
Yeah, that's what's really cool about it too. With CircuitPython, you just pop it in and the SD card loads and you can drag and drop whatever MP3 you want. You can easily assign new colors too, because when you click it, it actually outputs what the color values are in the REPL. So you can use different bricks, because Pedro had like some other colored bricks. He had some brown ones and some dark blue ones, because the kit I got didn't have those colors. So he was able to quickly like just
Yeah, I
without
got
knowing
like
how
I
it
have
works.
there's like the official colors and there's like the knockoff.
Oh,
Yes. They don't use the trademark colors, but then you get another set of colors.
there you go. Yeah. So yeah, check it out. We got the Learn Guide. It's up now.
Yay.
And yeah, you guys will let me know how Luna likes it.
Yeah.
Cool.
All righty. Thanks so much. All right, we're gonna go to Dan and then Tyeth. We got a couple extra folks coming in. This is great, and we're not doing live Ask and Ninja. We're probably gonna do a little bit of pre-record, so you got time, but maybe keep it a few minutes each. We'll get you out of here right away. Dan, how's it going?
Hey, how you doing?
Great.
It's been a couple years since I've been on here because I always have something going on Wednesday nights, but with the snow and all that.
Yep.
I'm
Good
here.
time to share.
Yeah. So I've been having a lot of fun with the Fruit Jam. A couple months ago, I ported Zork in the Z machine to the Fruit Jam and CircuitPython, and been doing some other things. And I guess a month or two ago, I made a suggestion to the Fruit Jam OS GitHub to say, it'd be nice to have some screensavers. And Tim.Molt liked that idea so much that he added it. So I thought, well, maybe I need to make a screensaver too, since it was my idea. So I guess maybe about 5 or 6 years ago, I wrote a Learn guide using a maze maker with a Metro M4 and an e-paper display. I thought, well, I want to try that as a screensaver. So I'm going to see if I can bring it up. Let's see if I can switch my camera here. Well, I thought I could switch the camera. Oh, here we go. Let's see. Can you see that?
Yeah. This is the floor plan for the Shining last scene, is it? No.
So what it does, it generates a maze and doesn't know the solution, so it goes ahead and figures out the solution on its own. So it's kind of like a mousetrap, and it's interesting because this is kind of like mirrored from what I'm seeing, but it's kind of like a mouse making right turns all the time and eventually gets to the other end. So that's what this is doing. And so the screensaver brings this up, generates a new random maze, and then it solves it, and it does that little mouse dropping thing. So you can actually see it being solved in real time, which I wasn't able to do with the e-paper device because, of course, you've got, the slow refresh rate. But this it's pretty quick, and it goes through. And
Wow.
So it's kind of like making right turns.
Yeah.
More or
Reminds
less.
me of the slime mold, that makes the rounds every few years. It's like the slime mold figured out a way through the thing. We should have slime molds run everything. And we should. I agree with all that. this is super cool. So where can folks find out more about this?
Yeah, so I'm going to do a playground article when I get this done. So you can look for it there in a week or two.
Right on. And, you know, maybe because it's open source and there's a lot of people who use our stuff for scientific research and more, maybe a slime mold will control this one day.
Yeah.
I'm looking forward to the first slime mold on the show and tell. Okay. Thanks so much, Dan.
So yeah, but just it's the Fruit Jam is a great idea. So I'm having lots of fun with it.
And it has HDMI out, so you can have that on any screen that's just sitting there doing nothing. Put in
Yay! Thanks for doing the screen. Yeah, when you had that idea, I was like, "That's a good idea." Like what's the best thing about old computers is like screensavers, because we don't need them anymore.
Yeah.
But you know.
Yeah. Also, I wrote a Star Trek one with the Starfield. You know, going.
Oh
yeah.
So that's another one that I'm working on.
Okay.
Alrighty. Okay.
Yeah, people love screensavers. It's like demos, but like you get to play with them all the time.
I was telling Lamore about a scene in the first episode of Next Generation in Farpoint, and I'm gonna ask her to rewatch it because I think it would be good.
Been a lot. I've seen it like 2 or 3 times. I've seen the first episode, but I still remember it.
Well, if you saw it like 30 or 40 times, I think you'd enjoy it more. Okay, let's go to Tyeth. Thank you so much, Dan. Tyeth, what you got going on?
Hi everyone, hopefully you can hear me.
Yeah.
Wicked. Okay, yeah, so I've been doing a little playing after seeing a user in the Discord talk about this old M5 stack device.
Right.
Let me share my screen. Effectively, it's an ESP where you can bolt on these extra cases or faces as they called them. Sadly, it's been end of life, so it's no longer supported. And they came in asking, hey, look, it turns out this keypad has an Arduino in it, an Atmega 328.
Oh,
and can I use that for seesaw, or is there an easy way of me doing like I2C connection between that keypad and the ESP brain? And I was like, surely that must be possible. I know basically us at Adafruit, we sell these seesaw boards. You can buy them individually where you build your own hardware, and they're using these AT-Tiny chips. But they don't support the Atmega larger chips. And so I thought that'd be a great project to just chuck at an LLM. I love these seesaw devices because it means you get an easy way to use rotary encoders, NeoPixels, and all that kind of thing in one tiny I2C device. So we've got a seesaw peripheral library. That's the actual code that works on the AT-Tiny. And then we've got a seesaw normal library, which you would use to interact with the device. I've effectively asked code to have a go for me. It's had a really good go at it, actually. It's done examples for all of the different sort of versions. I've also got to do the Circuit Python code because I've been adding a Pimeroni board. The reason I was adding the Pimeroni board is because it's a really good sort of explorer board in the sense that it's got a breakout kit and all these other things. So let me stop sharing my screen a second and try to tilt you forwards.
Okay.
So I will pick these up individually, but the idea is this is the Pimeroni Explorer. It's running CircuitPython with a nice display. It's got a little breadboard on it and a couple of GPIOs and a quick connector. Now I'm just using the quick connector minus the power, so ground, data, clock, directly into this Arduino Uno. Happens to be an Elgu clone, but it's basically the same thing. And then I'm using the GPIOs from that into the breadboard, these orange wires. And then I've effectively got NeoPixels breadboarded off of that, and that's what's running here. So CircuitPython is running this rainbow test effectively through I2C on the Seesaw firmware running on the Atmega, and it works really well. I really want to test the rotary encoders, and I haven't got a keypad yet, but there'll be one turning up soon. So yeah, just to say, enjoy playing with LLMs. They are amazingly good at porting code. You still need to check things. You can even ask them to review their own stuff. But
all the disclaimers. Ain't nobody wants to port code.
No.
Not have a robot do it. No one's like,
it would just be like, good luck. Like if someone does it, you know, congratulations. Like some like random Bulgarian guy might come right through and be like, hey, it happens to be that I also want to do it. And I spent like 8 hours, but with an LLM, it's like you can just blast through it. And like, if it works, great, because you're like, I'm not shipping this in a medical product. I just want my little M5 stack keyboard to work again.
Exactly that. And the number of like tiny nano clones and other things that people have makes me think surely there's a reasonable market for turning them into equivalent of seesaw devices. A lot of people just want a few rotary encoders and a NeoPixel or something like that. It's a nice, simple solution. And also MicroPython have recently added I2C target and I2C slave and stuff, so you can do the equivalent of MicroPython. But of course, the old Atmega boards don't have enough oomph for that. So yeah, you might want a Pico, but if you've got all these old boards, you might as well.
Dude, people have so many 99-cent Arduino Nano clones. It's like ridiculous.
So a friend gave me one 2 weeks ago, and that's why I've done this basically. Yeah.
That's funny. It's probably not an Atmega chip. It's like one of the GD328s. It's a knockoff.
Claims it's a proper one and it's DIP, but well, I doubt it. Yes.
The example I like to give folks is I saw the auction for Steve Jobs, like handwritten and printed work that he was doing at Atari when he was 20. And it was an astrology program that he did the trig himself. And it never turned into a game. It was the printed thing and they were auctioning it off. So I'm like, oh, cool. I'm just going to download it, OCR it, scan it, and let me try to see if I can write Apple II stuff. Like, let me try to get it. And I did. And it was because I was like, well, here's a repository. Here's a thing. Here's an emulator. And it was like back and forth. And then it worked. And I sent it to someone who knows the family. I'm like, here's, something you could send along to the children and some of the family members. Like, this is something that he did when he's younger. And here it is for the first time. And of course I ran into the problem like, oh, cool. Let me put like my daughter's birth date in there. Nope. Stops at 1999 because.
Of course. Yeah. The classic.
Yeah. And so,
that's true, isn't it?
Yeah. But what's interesting is so there was some astrology people that said, wow, he knew what he was doing at the time. So if it didn't work, maybe that would be a story, but it did work. And because it worked and it was fine, that's not a story. But
I'm pleased that you also mentioned that you included tools so when using LLM, it's really helpful if they have a way of producing solid output rather than guessing themselves.
Yeah.
Like running an actual command that produces a standard report, i.e. an emulator does similar. It would run the game and report a crash if it crashed. And so you basically give it all the tools to help it check its own work.
The blanket statement of things like, I don't know, there's reverse engineering tools that have been around forever. What is that? Is that AI? No, it's like, it's a thing that looks at a database and tries to do stuff. That's kind of what we're doing. Like, I understand that there's this giant word that's being used for everything because there's so much money that everyone's bet on it. But for the people who are prolific and use tools, they're tools. I have a Bosch drill that has like a DRM battery. It sucks. I have a battery that isn't DRM'd that I really like. And I have like jailbroken local LLMs that doesn't leak out information. Like, we're probably going to have to show everybody how to do that too. And that's fine. That's our job.
I think that's it. It's obviously the way forward. Once they get as quick and snappy as you need them to be when run locally, it will be a no-brainer. Everyone will be doing it.
Yeah. And open source is the way, because why would you ever let anything like have control of your stuff? And if you can't break it and you can't, there's a subscription, you don't own it. So like, this is the way. It's not the way for everybody. It's the way for us. So tune in, everybody, as we try to find the plans of the Death Star so we can blow it up and make something better.
That's it. Keep reinventing.
Yeah. All right, cool. Well, thank you so much, Tyeth. Appreciate it. Oh, where could folks find out about this if they want to find out more about it?
Oh, yeah, sorry. So if you find the Adafruit Seesaw peripheral repository and look under forks, you'll find mine. I will pull request it eventually back to the main repository once I've tested it properly, because it might be useful. It's not a big extra block of code that will damage the original code, if you know what I mean. It's
cool.
Carefully done in tandem. Yeah.
All right, good stuff. Thank you so much, Tyeth. Alrighty. Okay, everybody, that is our show and tell. We'll see everybody next week, same bat time, same bat channel, 7:30 p.m. Eastern time. We're probably going to try to do some recordings and put up something that resembles Ask an Engineer. It might just be some of the highlights of some of the things we're doing on our desk this moment. So it'll be a little different, but we're just getting spun up for doing shows all the time soon.
Break time's over.
Break time's over. As you can tell with the embroidered badge that Lady Ada is
this baby eats forever.
Yeah.
So
Baby Ozempic. It's an idea. It's a bad idea. Okay. We'll see everybody later. Bye-bye.